Hey Chem Kids, Mr. C here, and today we are going to talk about ionic nomenclature. So we're finally going to use the names of the elements and the names of the polyatomic ions, and we're going to learn how to name different compounds. We're going to learn more about what these compounds actually are in a future unit, but now we're just going to learn how to name them if we're given the compound, like we're given the symbols, or if we're given the names. And first, we're going to talk about ionic compounds. So an ionic compound is composed of a metal and a nonmetal or a polyatomic ion. So it might be something like, hydrogen and aluminum, or it might be potassium and oxygen, but it's going to be a metal and a nonmetal, or it could be a polyatomic ion. So like it could be, sodium and sulfate or something like that. But they're always going to refer to a metal and a nonmetal, so a positive thing and a negative thing, and we refer to them as salts, and they have a few properties. You don't really need to know this for nomenclature. This is going to be more for whenever we talk about stuff later. So I don't feel like you necessarily have to write down all the properties, but they have high melting points. They're going to be usually solid at room temperature. They conduct electricity when they're in water, and they're going to be brittle when they're in their solid state. But once again, you don't really need to know that stuff for naming them. All you need to know for naming them is that they're going to be composed of that metal and a non-metal. And let's change the color of my pen. So whenever you have these, there's two different types. You have binary versus ternary, and binary compounds are just ones that are composed of two elements, whereas the ternary compounds are going to be composed of an element and a polyatomic ion. So that's the difference. Binary is just two elements, so it's just going to be two element symbols, and ternary is where you have an element plus that polyatomic ion. Come on, let's go to the next slide. We can do this. No? Too far. So let's look at naming ionic compounds. So the first thing that we're going to do is we're going to write the name of the cation first. All that is it's the metal. It's what's positive. So we write what comes first. So this is if we're given the symbols first. So we want to go from symbols to the name. So like maybe we have something like, what's it? Oops. So maybe we have something like, I don't know, NaF. So the first thing we're going to do is rewrite the name of the first symbol. So like in this case, it'd be sodium. And then we follow the name by adding the name of the anion, or the anion, that's just the second name, or the second symbol. So like in this case, the second symbol is the F, so this would be sodium. And because it's an element, if it's ever an element, we're going to talk about the polyatomics later, but for an element, we just change the ending to I. So instead of being fluorine, we change it to fluoride. So the name of this compound will be sodium fluoride. So let's look at a few examples. So the first one, we have K2S. So the first thing we do is we write the name of the first thing. So K is potassium. And then S is sulfur, but because it's just that element, we're going to change the ending to I, so sulfide. The next one that we have is Al2O3. We write the name of the first thing, so aluminum. And then we write the name of the second thing, so it's oxygen. Because it's just an element, we change the ending to "ide", so it would be oxide. And then we have MgF2. We write the name of the first thing, so magnesium. And then the name of the second thing, fluorine, but because it's just that element, once again, it's going to be fluoride. So this would be magnesium fluoride. I think I spelled that wrong, but that's okay. So the numbers like that you see here, they don't really matter when we're naming them. We're going to learn how they get those numbers in a little bit, but the numbers don't matter for naming them. So you just write the name of the first thing, and then if it's just an element, you change the ending for I. So let's do these. Try the ones on your sheet next, and I'll go over them. So pause now. Hopefully you tried them, but if we look at BES, we write the name of the first thing. So the first thing is just beryllium. S is sulfur, but because it's just that element, we change it to I, to sulfide. And then the other one was Li3N. Well, Li is just lithium, and we write the name of the first thing, so it's lithium. N, it's just an element, so it's nitrogen, but we change the ending to ide, so it'd be lithium nitride. Not too bad. Let's say we have a ternary compound, though. It's a very similar procedure. You still write the name of the first thing as is. So, like, you write the name. So, like, if it's K, you just write it as K. And then it's even easier for the second thing, or that polyatomic ion. You just write the name of the polyatomic ion, which is super duper easy. So, like, let's look at a few examples of this. Let's say we have 3 PO42. What we would do for this one is write the name of that first thing, so calcium. And then we just write the name of the polyatomic ion, because the second thing's a polyatomic ion, so it would be calcium phosphate. For, let's say we have like NaOH, we write the name of the first thing, so sodium. Well, OH is hydroxide, so this would just be sodium hydroxide. And then finally we have, oh, this is a cool one, NH4, 2, and then CO2. No, CO3, oops. We write the name of the first thing, so ammonium. And because that's a polyatomic ion, but we still just write the name as it is. And then the second thing is another polyatomic ion, so we would just write the name as that is too. So it would be ammonium carbonate. So for the polyatomic ions, or those ternary ones, we don't have to change anything, which is super duper cool. So now you had Ba, SO3, and then you have Li2, SO4. So go ahead and pause and give this a try. Hopefully if you try these, you got the first one to be barium sulfite. And for the second one, you should have got it to be lithium sulfate. So now let's look at our periodic table. So for the next thing, we need to know about charges and like what charge everything takes. And the periodic table is a very specific way of looking at charges. For the purposes of right now, we are not going to look at the center of the table. We're going to do that later. So we're just going to look at these the columns in the S block and the P block. Everything in column 1 will take on a +1 charge. Everything in column 2 takes on a +2 charge. Everything in this column 13 with boron takes on a +3. Carbon can be plus or -4. So everything in that column is plus or -4. Nitrogen will always be -3. The column with oxygen is -2, and fluorine will be -1. And noble gases in the end, they don't take on any charge. So this is what the charge will always be for these polyatomic ions. So we're gonna see how this factors into naming them. Now we're gonna look at naming them. So now we're looking at going from words into symbols. So the first thing that we need to do is we need to write the name and the charge for the positive ion. Sorry, not that, but write the symbol for the positive ion and the charge. Then we're going to want to write the symbol for the negative ion and its charge as well, or the polyatomic ion if it's a polyatomic ion. So we want to include the charge. So for the example that we're using in here, we're doing sodium nitride. So sodium nitride, sodium is Na, so I would write Na. And the charge on sodium, because it's in column 1, is a +1. Then for the second thing, we have oxide or nitride, and nitride is nitrogen. So anything that ends in an I, it's just going to be an element. Nitride is nitrogen, so we would write an N. And N, because it's in that column 15, will always take on a -3 charge. So we would write -3. So that was step 1 and step 2. Step 3, we're going to crisscross the charge and we're going to get rid of the sign. So like the 1, we're going to crisscross down here. And the 3 is going to come over to here. And we're going to forget the charge. Step 4, we need to check and see if we can reduce anything to lower terms. So like 3 and 1, we can't reduce that. Like they're not divisible by each other. But like let's say you had a 2 and a 4, because 2 goes into both of those, we'd want to divide them both by 2. And then finally, our last step is we just write this as our final answer. So like our final answer for the symbols for sodium nitride would be Na3N. Anytime we have a 1, we don't have to write it. Not too bad. Let's look at a few examples. So for the first one, we have calcium phosphide. So the first thing we do is we write down calcium, so Ca. It's in column 2, so it's going to take on a +2 charge. And then we have phosphide. It ends in an "ide," which means it has to be an element, which in this case is going to be phosphorus, because when you change the ending of phosphorus to "ide," it becomes phosphide. So that's P. And if we look at P, P is in the -3 column. The next thing we want to do is we want to crisscross those charges. So like the 2 is going to come down here. The 3 will go to calcium. We get rid of the signs. We look and see if we can reduce. We cannot. There's no common factors of 3 and 2. So we write our final answer as Ca3, P2. Let's look at aluminum nitrate. So aluminum nitrate. First we write aluminum. So aluminum is Al. It's in that column 13, so it takes on a +3 charge. And then we have nitrate, which is NO3, and it takes on a -1 charge. Then we're going to crisscross. And this is an interesting case. So the 3 comes down here and the 1 comes down here. Anytime you have a polyatomic ion, and this is the answer to the question right below this box, but anytime you have a polyatomic ion where the crisscross charge is not 1, you're going to have to put that ion in parentheses. So if we look at these, there's not any reducible term. So this would become Al. We don't write the 1. But because the charge on aluminum was 3, so whenever we crossed it over to NO3, it became a 3. We have to put NO3 in parentheses, and then we would put down here. So aluminum nitrate is actually Al parentheses NO3 parentheses 3. My rule of thumb on this is usually anytime I have a polyatomic ion, I always put it in parentheses because you can't go wrong with parentheses. So let's look at some more Oh, I did these 2 examples. Cool. So we already did those on that other page. Let's go ahead, do these on your own and see if you can get the right answers. Hopefully, if you did these on your own, you got, so this would be Na and then O. The charge on sodium is 1. So it'd be Na2O. For aluminum sulfide, it'd be AlS, the charge. So that would be 3 and 2. And then we have barium sulfate. So barium has a +2 charge, but sulfate also has a +2 charge. So it would just become BaSO4. One last note to remember on this, anytime you have that ionic compound, it should always be composed of a positive thing and a negative thing. You'll never have 2 positive things and you'll never have 2 negative things, and we always write the positive thing first. So what I want you to do next, and I'm sorry about the length of this video, I know I told you guys it would be like 10 minutes, but it's 12, so I do apologize about that. I rambled on a bit. But now I want you to go into those packets, and if you flip the page over on your notes, you should be able to do all those ones for question 1. So A through P for naming those ions. Let me know if you need any help or if you have any questions over this.